Hey everyone, this is part 2, the technical deep dive for days on market using analytics. And specifically, we're using Python and Databricks dashboard. So in case you are new to this, please refer to the previous video, which is the part 1. In this video, we're going to be going over the latter two charts within the dashboard, which is the yearly change, a little bit of statistics here, and then a deep dive into an actual township and look at how that chart was created. My name is Ariel Herrera, your fellow data scientist of AnalyticsAriel, where we bridge the gap between real estate and technology. If you have any questions, please feel free to message me. As well, make sure to subscribe to our channel. So let's get started. This yearly change over here that we have is an assessment of actually diving a little bit deeper, going from county into the actual township, because this is what we're actually going to be potentially as an investor looking into to get properties in. So what we're doing here is we're taking our other data frame called DF City, and we're doing the same application or transformation as we did with the prior data frame, where we're going to melt it. What do I mean by this as a refresher is up here where I actually have the raw data frame. We have information such as size, rank, all the way to state name. But when it comes to the actual days on market, the way it's broken out is that the year and the month has its own column, which isn't that useful. We want to see this instead of across 20 different columns plus, we want to see it in one single column. That way we can refer to it and say, let's look between January of 2010 to January of 2015 without having to mess with the columns. We could just do that directly from the rows. So what we're doing down here, back to the yearly change, is we're melting this. Then we're doing a specification using pandas to locate where the state equals the widget state. The start trend is greater than what the user selected, and it ends before the user's widget as well. And that's why what we see over here is now for our date range, rather than that being a bunch of columns, it's now melted down to be in a single column that we can now specify. And you're probably wondering, hey, there's some other information that's there that I didn't see before, such as latitude and longitude. I have this function called get location information. For those that might be new to Python, a function is the ability to be able to write reproducible code and only enter in keyword arguments versus having to write this out each time. There's two different parameters that I have, which is the location and the Google API key, which is unique per user and you need to generate on your own. So the location, which is pretty neat through Google's API, is that whether you're feeding it a state, a city, a zip code, it's able to just infer that as address rather than you having to put one specific parameter. So here I have my endpoint where I'm getting the data, which is Google's API for geocode. My response is going to be back JSON format, which is like a dictionary. I'm inputting the URL. My parameters include the location, the Google API, and then from this information, as we saw previously over here, there's latitude and longitude, but it's nested within this format. So when I go back here, I'm basically extracting the county and then that information, that geometry from that. All right, so now skipping back down to the data frame, you can see that I have that information. I joined it previously, latitude and longitude, for each of those cities. So in this case, if I were to go down, let me get a good example where everything is populated. Okay, so in this case, Bloomfield, New Jersey. This is a city in New Jersey. I'm able to get the county. That was the previous data set that now I have merged together. The latitude, longitude, the days on market. So in this case, the way we read this is in August of 2019, the average days on market was 83 days. Now, this is new. Prior year days on market. What I want to get is the information of August of 2018. So that prior year, what was the days on market? In this case, it was 101. So it was higher. So when we look at the percentage change between the prior year and the current year, it ends up being about negative 17%. In this case, negative is good because we see that houses are selling faster. The number is going down. And this is the metric that we want to focus on. So that metric, I am actually creating that up here. So for that data frame, I'm creating the column prior year days on market first. So what I'm doing is I'm shifting all my information. I have everything sorted. Then I'm shifting it in order to get what that prior days on market is. And then when I'm looking at the change, I'm looking at days on market current minus prior year's days on market divided by prior year's days on market, which this is just a pretty standard metric if you ever want to get percentage change of something. It's great to have all this information, but what's really powerful is that if we can narrow down on things that we want to focus on, which is why I'm getting the top 10 here. That top 10 is what you see in this part of the data frame. So what I'm doing is, I noticed there was some missing data. As you could see when I scrolled all the way up, for example, Asbury Park, which is the city, didn't have information for a lot of the years. So I want to exclude that information. And when I go down, I have excluded where there is null, and I do that over here. So I look for all the regions where there's null value for days on market. And over here, I had this little squiggly, which basically means look for all the region names that were in that list that had null values and remove that from my data set. Then I want to group by the region, county, latitude, and longitude, and look at that percentage change days on market, which is going to be this data frame over here. And I only care about those where the percentage change is negative. Again, meaning that days on market is declining, because that signals to us a growth market. These are the ones we want to focus on. So I have that here as my new data frame. DF percentage change is negative. And the next thing I'm doing is I'm separating it out quantiles. So I want to group the data sets. I want to group them into buckets. So I want to get the lower bound of 33% between 33 to 63, and then the top. That way I have 3 different groupings, which is similar to here, high, medium, and low. Now, how else can I do this? So I'm going to make this really simple just to show you an example. Say if I had the numbers 1 through 10, for example. I'm going to write these out quickly. And how do I assess a grouping for these? What's high, what's low, what's medium? So that's basically what I'm trying to do with this quantile, is that in this essence, the lower bound would probably be like these 4 numbers, the medium would be these numbers, and then the high would be these numbers, as an example. But what's really great here by using quantiles is that you can set it manually and say, oh, I only think high, so a high change is 10%, negative 10% and below. But that's very static, and we never want our code to be static. We always want it to be dynamic because the distribution could change drastically. So that's why we are looking at quantiles versus actually doing it by a hard number. Let me remove the comments here. So once I do that, that's when I'm doing my labels, the high, the medium, and the low, based upon if this value in the data frame is less than or equal to the lower bound, and so on. And that's how down here I'm actually getting that value, whether it's high, medium, or low. And then I'm also providing a rank so that I could see the top 10 counties. Rank, super easy, literally just specifying a data frame, the column that I want to rank by, and then rank. And that's what we see here. That is what is in the data frame over here. And when we put this into the data frame, we do drop down here, click the dashboard, it sends us over here, drag and drop. In this case, I might want to expand this further because as we could see when we contracted it, it did lose out on some of the information. But what I love about Databricks is that it's really easy to just scroll between within a dashboard on a table. So this is awesome, but what if we want to understand, maybe there's trends up in areas. Maybe we see that there's different pockets in New Jersey that has cities with drastic changes from year over year. And that's why I plotted this over here in this chart, this geographic chart, which is actually my favorite using Plotly. And look at this, it's barely any lines of code, right? I mean, it looks like a complicated chart because it's so pretty and has all these different dots on them, but it was really easy to put together. I'm using the same exact data frame as above when we saw over here that latitude and longitude value is getting plotted here, those columns. Then I'm separating out by the value. So that value that I specified, whether I've deemed that change to be high, medium, or low, that's how I'm separating out these values. And then when you hover over it, I want it to have the region name. So in this case, I hover here and I could see different region names, Franklin Township. And then North Brunswick, the one that came up as our top change, is right over here. And we can see there's a lot of actual high values that we see in this area, which means looks like Central Jersey may be going through a growth spur between 2018 to 2019. So we see a lot of counties in the same area that are selling homes faster than the prior year, as well as Philadelphia and close to New York City, which all makes sense because there's been a lot of development within those areas because it's hot spots for commuters to get into both cities. And now that we have our top one here, we want to dive a little bit deeper into what those days on market year over year actually look like. So if we go back, this is the deep dive. And what I'm doing is I'm giving the user the option to actually select any of those regions. So I have the data frame, I'm sorting by the region name, that way it's easy to find. Make sure only unique values to a list, and this is the list here. So when I specify that into a widget, then I'm only selecting the top widget. Sorry, I'm selecting the top value. So in this case, my top value was North Brunswick, so I want that region name to come to the top. And that's why I have that here. Then when I'm actually plotting it, I'm using a bar plot. So I'm looking at the region specifically, which is North Brunswick. And what I want to do is make sure I'm only looking at that region, which is why here I'm using pandas to locate where that region name equals that selected city, then focusing in on a couple of columns. This is going to be labeled data frame graph, what I want to actually chart. So I specify that here. For the x-axis, I want the months to go across, which is down here. And I want to look at days on market vertically on the y-axis. Then I want it to be separated by year, because I'm comparing 2 years. That's my differentiator. So the column year is what I'm going to be separating it by, which we see here, 2019, and then I click back to see 2018. My title, I want it to be dynamic. So when the user selects different trend years, as well as city, I want that to be updated automatically. And then the layout, instead of it being 01, 02 for January and February, I want it to actually have that 3-character abbreviation, which is done over here. And then to make sure that the range of this data frame is specific to each chart for days on market, I am selecting the max amount of days on market and having that as my range for the y-axis. In 2018, for this town called North Brunswick, it was 168 average days on market in 2018. 2019, less than half that, okay? And this is consistent across several of the months. This gives us that quick insight in order to understand the behavior. I also am familiar with this township being in Central Jersey, that it's close to State University, Rutgers. It also is close to major transportation centers for public transit going into New York City as well as to Philly. Knowing this information, I can attest that the year-over-year change does make sense, and this gives our users the ability to quickly zone in. So I hope from this technical deep dive, you've really been able to understand how we can manipulate a simple Excel file and actually get really great insights from it. This is just one single metric, days on market. Can you imagine how powerful this could be if we use all 5 economic factors from the original presentation that I had given in that video? We could really do so much. So please feel free to reach out to me if you have any questions about plotting in Python, as well as collaborating on particular data sets for real estate. And of course, subscribe so you can get more videos and notifications about this topic. Thanks so much, guys.